Welcome back. Today we're going to be working on Congruence day number 1. Our content objective is students will be able to determine if two figures are congruent based on the definition of congruence. Language objective is students will be able to describe the properties of congruent figures that follow from the properties of rigid motion. Why am I learning this? Well, it's important for real world problems like creating video games. So quickly, let's go ahead and refresh our memory of the different types of transformations we've learned thus far. We've learned about translations, which is basically sliding a figure along a line without it turning at all. Rotation is basically when you rotate a figure around a fixed point, which is the center of rotation. And of course, we went over reflection, which is basically flipping a figure across a line to create a mirrored image. So from our previous lesson, we've talked about how translating, reflecting, or rotating basically creates congruent shapes, which is going to mean that all corresponding parts are congruent, which means corresponding sides are congruent, as well as corresponding angles. And we know that figures are congruent whenever they have the same size and the same shape. So let's go ahead and take a look at the very first problem. It says, describe the ways in which the figures are the same and the ways in which they are different. So the first thing that comes to mind is all the corresponding segments are the same length. Okay, from your pre-image to your image, none of the lengths were enlarged or decreased. They're exactly the same. What else? Well, the corresponding angles are exactly the same. The measurements of the angles weren't altered whatsoever. And another thing is the lines that were originally parallel remain parallel even after the transformation. So these three main things you're going to notice is going to happen whenever we're looking at these types of rigid motion, which includes rotation, translations, and reflections. Now, what wasn't preserved was the orientation of it, basically its placement on the plane. It definitely moved to a different location. So in other words, the two figures are said to be congruent because they have the same size and the same shape. Okay, a two-dimensional figure is congruent to another if the second can be obtained from the first by a rigid motion. So again, rigid motions include rotations, reflections, and translations. Or if you can use a sequence of these rigid motions. So maybe you had to use 1, 2, or maybe more different types of these transformations to get to the pre-image to the real image. So basically, if you can move one of the figures using one of these transformations or a series of these transformations so that it fits exactly on the other one, then you know for a fact that the two figures are congruent. So basically, any type of rigid motion will preserve congruence of a figure, which means whatever shape you start with is the shape that you will end up with. So now let's go ahead and go over some quick vocabulary. The first one's congruent figures. Okay, congruent, first of all, the symbol that we use looks something like this, a little squiggly line on top and equal sign underneath. So this is basically when you have the same size and the same shape. We've definitely taken a look at these characteristics whenever we talked about the different transformations. We always check to see if it preserves size, shape, and orientation. So essentially, if you're able to say yes, same size, yes, same shape, then you can come to the conclusion that the shape is congruent. Okay, the next vocabulary is correspondence. It's basically a way of matching up two sets of objects. And you're going to see a little more and maybe understand it much better with the examples that are going to come. We're going to go ahead and move right on to our next example. Here it says list the corresponding angles and sides if quad, real quick, quad is just a short way of writing quadrilateral. So here, this means quadrilateral HIJK is congruent to quadrilateral NMLO. And for those of you who may have forgotten, quadrilateral is basically a four-sided polygon. So In order to do this, first you have to recognize that this here is called a congruent statement. This congruent statement tells you a lot of things. So if you're able to at least write or find the congruent statement, you're going to be able to answer quite a few questions referring to corresponding angles and corresponding sides. So let's go ahead and first start with corresponding angles. The first thing I want you to understand is kind of like I mentioned earlier, corresponding means the matching set. So here, notice H is the first letter in this congruent statement. So I'm going to go ahead and say angle H is corresponding to angle N because they are both the first letters of the congruent statement. So for that reason, I'm able to say that angle H here is congruent to angle N. So notice I went ahead and used one tick mark to represent that to show me, okay, so these angles are congruent. So I can go ahead and write angle H is congruent to angle N. So this is basically my way of annotating on top of the diagram so that I can quickly assess what angles are congruent to what. Okay, so let's try the next one. Now from here, I can go ahead and say, continuing the same process, angle I is congruent to also the second letter in this congruent statement, which is M. So I can go ahead and mark that. Now I can't use one tick mark because that's already used for H and N. So I'm going to go ahead and this time use two tick marks. So I'm going to go ahead and put two tick marks for I, like so, and do the same for M. So again, that quickly tells me right away which corresponding angles are congruent. Now, right now, I'm making it just a little bit easier by color coordinating it. But again, the number of tick marks will also help because let's face it, we won't always have different colored writing utensils to kind of illustrate that for us for every situation. So that's basically why we used a different amount of tick marks to show that. So I'm going to go ahead and write that as angle I is congruent to angle M. Again, I'm going to continue this process moving on to the very next letter. So here I can say angle J is congruent to the third letter, which is L. And once again, I'm going to annotate that. I already used one tick mark, two tick marks, so of course the next one would be 3. So I'm going to go ahead and put 3 tick marks for J, like so, and also put 3 for, let's see, L. 1, 2, 3. Okay, so I'm going to go ahead and also then write that in. Angle J is congruent to angle L. Now we just have one last letter, so let's get to that. Notice here is the very last letter, so I'm going to go ahead and say angle K is congruent to the very last letter in this congruent statement, which is O. So I've used 1, 2, 3. Let's go ahead and put 4. So we have 1, 2, 3, 4. Kind of looks like a rainbow there. We're going to do the same thing here. 1, 2, 3, 4. So now I'm going to go ahead and write that as angle K is congruent to angle O. So notice this congruent statement made it very easy for me to find the corresponding angle just by position. First with first, second with second, third with third, fourth with fourth. It's that simple. Now we're going to go ahead and repeat this process with the side lengths. Okay, so very similar. First of all, understand that this is a quadrilateral, so how many sides is there altogether? Well, there should be 4 of them, so just keep that in mind. So, the first thing I'm going to start with is understanding that in order to look at a side, there's at least 2 points. There's 2 points. So, here I'm going to go ahead and start with H and I since they are the first letters. So looking at segment HI, which is this one here, that would be congruent to segment NM. So I'm just going to go ahead and put one tick mark. So HI is congruent to NM, so which is this length here. And you can even see it is the length that is closest to the 1 and 2 tick marks. Okay. Okay, so I'm going to go ahead and write that as line segment HI is congruent to line segment MN. Notice I purposely went ahead and reversed. Instead of putting NM, I put MN. Now, does it really matter? Absolutely not. It's just a side. NM is the same as MN. So just keep that in mind. Now, if it bothers you and you want to put NM, that's totally fine, but I just wanted to show you that this is okay. Okay, so notice also we are using this bar right on top of the variables to kind of indicate that it is a line segment, the same way we use this shape that kind of looks like an angle to represent that it's an angle. Okay, moving on. So we went ahead and used the first two letters. So now all I'm going to do is go on to the second and third. So IJ is therefore going to be congruent to ML because they're both the second and third letter in the congruent statement. So here I'm going to go ahead and mark it. I can't use one, I have to use two now. So IJ, so two tick marks there, is congruent to ML. And then I can go ahead and write the congruent statement like so. IJ is congruent to ML or LM. Again, it does not matter. Okay, moving on. Now moving on to the third and fourth letter. I'm going to go ahead and say JK is congruent to LO. So now let's annotate that. JK, which is right here. 1, 2, 3. Notice I had to use 3 because that's how many tick marks we're on. So 1, 2, 3, and I can annotate that as JK is congruent to LO. And notice again, LO, OL does not matter. And then you're probably wondering, okay, what about the last one? We've kind of reached the end. You know, what's the other point? Well, then we go to the end. We can go ahead and say first and last. HK is congruent to NO. So let's go ahead and you'll notice there's yet another length, and you can see that. Look, it is HK. So 1, 2, 3, 4 is congruent to NO. 1, 2, 3, 4. Now, once again, it really doesn't matter which order you write it. I went ahead and wrote segment HK is congruent to NO. Now, could you have reversed these? Absolutely. The order of these letters do not matter. So basically, what I want you to get from this is quadrilateral HIJK has been rotated to create quadrilateral NLMO. So hopefully you do see it's just a rotation. And because it's a rotation, and a rotation is a rigid motion, we know for a fact that it does preserve congruency, which means they are the same. Okay, so now what we're going to do is go ahead and take a look at different figures and write our own congruent statement. So here, I'm going to first just go ahead and say, I'm going to start with triangle ABC. Now, what is that congruent to? Well, first, I'm going to go ahead and write triangle and then find its corresponding point. So A corresponds to Y. And how do I know this? Well, because they are both the right angle. So I'm going to go ahead and put triangle Y. Well, what does B correspond to? Here, notice A is going to the shorter side, which is B. So for Y, I would want to go to Z, because X would be the longer length. So I'm going to put YZX. So this here would be my congruent statement. Okay. So now here, again, what you want to do first is just go ahead and label your, in this case, your quadrilateral. You can go in any order that you want. I went ahead and used quadrilateral LMNO, so that's the particular order that I went. Now, could you have went and said MNOL? Absolutely, whatever works for you. So there's no real wrong way to choose your first letter. You can choose whatever one you want. Now, the most important part is you understand that at this point, when you selected an order, you have to make sure the next set of letters are written in the correct order so that they correspond to the correct variable. Now, this can be a little tricky when it's basically any shape that it's more than 3 sides. So for anything that has more than 3 sides, what I like to do is number the lengths from shortest to smallest. Sorry, from shortest to longest. So here I'm going to go ahead and say this is the shortest length. This is the shortest length. Now the second shortest length would be this one here, and that would correspond to this length here. Now between these two, I would say this is the longest. So that would make this one 3 and this one 4. This is the next shortest length and this is the longest. So at this point, this kind of gives me a general idea of how I should go ahead and finish this congruent statement. So I'm going to go ahead and use QUAD, which is basically, once again, short for quadrilateral. Starting with LM, that's the length of 3, going to N, so it should be 3, 1. So here I'm going to go from 3 to 1, so I have to start with CBA. So notice how I did that. I'm going to write it real quick, CBA. I couldn't say ABC because that would be going from short to 3. So hopefully you're able to see that. So once I've determined this, I can just go ahead and finish it. That's CBAD. So there is my congruent statement. So this is basically my strategy of figuring out how to write it. If you can come up with your own, feel free to use that. This is my, once again, my personal strategy for any shape that is greater than 3 sides. So with that said, I want you to go ahead and pause the video and try 3 and 4 on your own. Okay, so let's see how well we did. Hopefully for number 3, you were able to at least visualize it well enough and not have to use a strategy that I did in the previous one. So let's see how well we did. This one has 1, 2, 3, 4, 5 sides, so we wouldn't obviously call it a quadrilateral. Instead, it's referred to as a pentagon. So here is the answer that I have. I have pentagon ABCD is congruent to pentagon PONML. Now, is it possible that you came up with a different answer? Absolutely. You might have started with a different variable. Maybe instead of starting with A, you started with a C. Hopefully you still recognize that it's still going to be in the same order. C, D, E, A, B is congruent to N, M, L, P, O. Or you could have gone backwards and said, for example, B, A, E, D, C is congruent to O, P, L, M, N. So please understand there's more than one answer, but as long as you're going in a successive order. Now for 4, I have triangle EFG as congruent to IJH. And there you have it. Now, to keep things very similar to possibly your classmates and my answer so it's easier to check, it might be a good idea to always start with the first letter in the alphabet so that you have a good idea of where to start, and then go to the other letter that would follow it. Just a suggestion. Okay, so for number 5, we're given a congruent statement. It says triangle ABC is congruent to XYZ. Now it's going to ask us some questions. Well, it says which line segment XYZ is congruent to line segment BC. So some of you will be able to recognize right away, okay, BC is congruent to YZ, which is great. Now, the other thing that I want you to recognize is you could look at visually, which is great, but sometimes if you don't have a visual, what are you going to rely on? Well, you can simply rely on the congruent statement. So once again, the congruent statement gives you a lot of information. You can see here, BC is congruent to YZ. The second and the third letter is congruent to the second and the third letter. So this makes it really nice and simple for me, because sometimes images can be misleading, which is not going to be helpful at all. Now here, line segment AB is congruent to what? Well, here, AB, again, some of you will be able to see right away, that's congruent to YX or XY. Doesn't really matter which order. But once again, you can simply look at the congruent statement. AB is congruent to XY. Whichever way you see it, do whatever is easiest for you. Next question, line segment CA. Again, you can look at it visually and see that it's congruent to zx or xz, or you can simply use a congruent statement. AC is congruent to xz. And once again, do you have to use this particular order? No, it does not matter the order of the line segments, of the letters for the line segment. Okay, now we're moving on to angles. Here it says, which angle of XYZ is congruent to angle A? Some of you can recognize right away, angle A is congruent to angle X just by looking, or you can simply use a congruent statement and draw it from there. Okay, I do highly suggest you rely on the congruent statement more than the visual, because there's a good chance that you may not be given a figure, which is not going to be very helpful. If you're given a congruent statement, that can get you pretty far. So I'm going to go ahead and put angle X. Now the next question is, angle B is congruent to what? Well, here, angle B, I can see right away is congruent to angle Y. But clarification, I can see, okay, B is the second letter here in the congruent statement, so it's got to be congruent to Y, which is also the second letter. So notice again, I'm using tick marks, and the amount of tick marks helps me identify which one it corresponds to. So I'm going to go ahead and put angle B is congruent to angle Y. And last but not least, angle C here is congruent to angle Z, using 3 tick marks for that. And we could even see it here in our congruent statement. So now what I'd like you to do is go ahead and pause the video and try number 6 on your own. Okay, so let's see how well we did. So here it says, find the measure of angle Q. So hopefully you can recognize, since it's not as easy to see here, angle Q is going to correspond to angle E, which means I know the angle of E is 50 degrees. So that means the angle of Q, the measurement of angle Q, must also be at 50 degrees. Okay, the next question is, find the measure of angle P. So here, angle P corresponds to angle D. I do know the angle of D is 60 degrees, so that should mean that the measure of angle P must also be 60 degrees, because we know corresponding angles are congruent. Okay, so let's go ahead and pause the video once more and try number 8 by yourself. Okay, so let's see how well we did. Here it says quadrilateral LMNO is congruent to quadrilateral CBAD. So here we're given some images and some angle measurements. Now it says here, find the length of a line segment AD. Well, here, segment AD, we don't know that, but we do know that AD corresponds to NO, which we fortunately know the measurement of. NO is 10 miles, so therefore I know that the line segment of AD must also be 10 miles. Now we're going to find the length of OL. We don't know it here. However, let's see, LO corresponds to DC. Do we know the measurement of DC? We do. We know it's 4 miles. So the line segment of OL must also be 4 miles. So notice once again, this congruent statement is really helping me out. I'm not having to rely on the figure alone. This makes it a little bit clearer for me. I know some of you are going to fall back on the figures because it's a nice visual for you, but if you learn to start to rely on the congruent statement, you'll get more comfortable at it, and it's very accurate. Okay, so if you can, practice using the congruent statement. Okay, so the next one, it says find the measure of angle D. Obviously we can't see it from here. However, we know that angle D corresponds to angle O. Do we know the measurement of angle O? We do. We know it's 80 degrees, so I know the measurement of angle D is also 80 degrees. Find the measurement of M. It's not given here. However, I know that M corresponds to B, which was given. It's 95. So I'm going to go ahead and say that is 95 degrees. Okay, so hopefully you got all of those right. So now moving on. Okay, so then I should ask myself, how do I know all of this? Well, I know this to be true because since I know that these two shapes are congruent, I know all corresponding sides are congruent, which is why I was able to answer these questions here. But I also know that corresponding angles are congruent, which is why I was able to answer these questions here. Okay, so that is going to conclude the lesson for today. Thank you so much for tuning in. And as always, until next time, bye.